Hello and welcome to this walkthrough of Optimum on HackTheBox. This is number 4 in our series of 10 machines exploited without the use of Metasploit wherever possible. We're going to depart from the usual Nmap scan on its own anyways, to expand to an automation tool that does a great deal more than just that, and that's auto recon. So we provided the IP that we're interested in scanning, similar to Nmap, and as you can see, the auto recon scan does run Nmap. It actually runs 3 Nmap scans, a quick TCP scan, a full TCP scan, and a top 20 UDP scan, so that you can check in on early results while the longer scans are doing their thing. It also runs Nmap scripts against detected services. You can see here that it's detected HTTP on port 80, and so it's running a series of HTTP-related tools and scans, including the NICTO vulnerability scanner, web vulnerability scanner, GoBuster for enumerating directories and files on the detected website, and so on. We'll give this a couple of minutes to finish all of its tests. We could look into a different window and see the early results. For now, we'll just let it run. You can pause the video and wait for your own results to come back, and we'll return when they do. All right. And our scan is complete. So as you can see, various scan elements are coming in at different times. Our quick Nmap scan, the top 1,000 ports, comes back in only 16 seconds. Our full TCP scan, as usual, takes about 2 minutes. But something like even scanning the top 20 UDP ports takes nearly 9 minutes. And things like NICTO take about 7 minutes as well. So this is a highly recommended tool for those approaching the OSCP. This lets you run auto recon against a number of hosts that you're going to be tackling for the test while working on something else, like the buffer overflow portion of the exam, and coming back to the results when you have time. As you can see, you can check into the results at any time. And we have them in the results folder, separated by the IP address. So if we go into scans, there are also folders in there for you to store important files to create your report in, but we're interested in the scans here. And there's a scan file for each of the scans that it's completed, including an error log. You can check if something's not working. For instance, GoBuster has failed to return correctly, but that's all right in this case. So if we want to have a look at our Nmap results, it's quite a long return for the Nmap scan that it's running, but we can see that the Nmap results actually for this machine come back quite simply. There's a website being served on port 80. That's basically it. If we were to look back into the NICTO results, we'd see that it detected a possible cross-site scripting vulnerability. That didn't pan out, so after some testing. Nmap also notes further down that there is a possible vulnerability related to HTTP verb tampering, that we could potentially bypass authentication if the HTTP method is changed from, in this case, get to head. Neither of those avenues pan out for exploitation, neither the XSS nor the HTTP method tampering. Nmap also notes that this server may be vulnerable to a denial of service attack based on CVE 2011-3192, which is a noteworthy finding and something that could be tested, but not an attack path that's going to result in a system-level access to the machine, which is what we're interested in for these scenarios. We can browse to 10.10.10.8 and see what service is running on port 80. And we can see that it's running HTTP file server 2.3. There are no files or folders in this home area that's being served up to us. The login link triggers a prompt for HTTP authentication. Without any valid credentials, we're just going to get a message telling us that we're unauthorized, that either our name or password don't match, and we're not permitted to access the resource. This login link is something that we could intercept with burp. That's how I tested changing the HTTP verb from get to head. And we could run brute force attacks against the username and password, but that is a long and very inefficient process. We do have information here, though. And if we were to Google the HTTP file server version 3, we can see that this is a possibly vulnerable version of the Rigetto HTTP file server. So we can see from the Rapid7 page for this vulnerability that there is a Metasploit module, but we'll set that aside for now. Looking at the CVE for this vulnerability, CVE 2014-6287, we can see that this vulnerability lies in the find macro marker function in the file server code in versions 2.3 before 2.3c, so presumably 2.3a and b. That function allows us to provide a URL encoded null byte, this %00 sequence, in the search field, and then any commands that we supply after that will be executed on the remote machine. This has been corrected in versions 2.3c and after, and the application really should be updated to the latest stable version, which is currently 2.3m in a real production environment. As we can see, there is exploit code on the exploit database, and looking through that code, we can see first that a lot of it is URL encoded, as indicated by these percents, but we can simply grab that section, copy that into the CyberChef, which is a tool created by the GCHQ, the British Intelligence Agency, and apply a URL decode filter to it. So this makes it a bit clearer what it is we're looking at. Parsing it out, what happens is that a file script.vbs is being created. The contents of that file really are simply a GET request to an IP address that we provide, in this case the IP address of our attack machine, looking for nc.exe, the netcat Windows executable. It's going to save that to a file on the remote machine in C users public nc.exe, overwrite any existing file there, and then run the script to make that GET connection. So we're going to be hosting through simple HTTP file server, or simple HTTP server, that file on our attacking machine. We provide it with our IP address, so it's going to look to our machine for that file, save it to the remote machine in the user's public folder. And then after that happens, it's going to run netcat.exe, have it execute a command shell back to us to the IP that we provided of our attack machine and the local port where we'll have a listener waiting for that netcat connection. So we can grab that exploit code, and look at it in this case Sublime, which is a little easier to work with than Vim. It's looking for us to change out the IP address to our local IP address, in this case 10.10.14.27. and we'll give it port 9999 for the port that it will connect back to, where we'll have our listener. And one thing to note here is that you may need to run it multiple times for success. In my experience with this, 2 is typically the sweet spot. So we'll save that. Next, we'll need to serve up a copy of nc.exe on using our local simple HTTP server. We can find a copy of nc.exe on our local machine, searching really anywhere from the root directory up for a file named nc.exe. And we can see that we do have a copy of that in our seclist web shells fuzzDB folder. So here we will run our HTTP server. Open a new section here. Next up, we need to set up our listener on port 9999 so that it has something to connect to. And lastly, we need to run the script itself. So it requires us to provide the IP of the victim and the port that the web service is running on. And in this case, we didn't need to run it twice. We are already set. So we can see that we are in a shell, puts us on the command line at C users costas desktop. And if we run who am I, we are the user costas in the Optimum domain. So listing the contents of this directory, we can see right away that we've got the user.txt file, in this case user.txt.txt, and there's our first flag. We cannot, however, access the administrator's area. Access is denied. So we still need to elevate our privileges to system. And for that, we can use the Windows exploit suggester, which will recommend possible kernel-level exploits based on the current security updates on the victim machine. Now for that, we're going to need the system information on the victim machine, which we can collect using system info. It will take just a second to run through that. We'll copy this information into a local file called systeminfo, or sysinfo. We'll run an update of the Windows exploit suggester. Mine lives in the opt folder in Windows exploit suggester, and we simply give it the -- update. And that will make sure that it has the most current database of vulnerabilities and exploits. So you can see it's marked for today's date. We provide that file as the database. And tell it where the system information is for the target machine. So it's going to run, it's going to compare all of those updates and patches that have been applied according to system info to vulnerabilities in the database. And we see that there are quite a few of them. So the simplest path here is to simply try them one at a time. I found that, well, the first one is a denial of service exploit, which is not going to be particularly helpful for us. The second one is privilege escalation vulnerability that did not work for me. So I moved on to this one, 41020, which is the region object exploitation. So this number here, the 41020, is simply a reference in the exploit DB. So we have access to that code. We could just go and grab it with Searchbloit, which will download the uncompiled C code that we see here. But we also have links to a compiled binary, so we can grab that with wget. And so that's on our machine here. Looking at the documentation, we can see that this code exploits the RGN OBJ integer overflow vulnerability, MS16098. So the RGN OBJ object is a graphics object, the region object, that defines an arbitrary region on the screen for graphics. An integer overflow in it causes the Windows kernel mode driver to improperly handle objects in memory, and an attacker can provide a crafted application like 41020.exe to cause that overflow on a variety of Microsoft Windows operating system versions. Everything from Vista to Windows Server, 2008, 2012, Windows 7, Windows 8.1, as we can see here, mentioned specifically in the exploit, Windows 10 up to version 1607. And this allows a local user, such as our Costas user, to run arbitrary code in kernel mode and escalate their privileges. Now the solution here would be simply to apply the security patch, really all of the updates and patches, but that's not always possible. But they could apply the Microsoft Security Update for Windows Server 2012 R2, knowledge base 317775, to prevent this privilege escalation method on this particular machine. So our next goal is to get 41020.exe onto the victim machine. Now, since we already have a solid method for moving files onto the remote machine with the 39161 script, we can modify that to make a script that just transfers files to the victim. So if we create a copy of that, call it mover.py, well, we no longer need the section where it executes netcat for a reverse shell. And that's being defined in this nc run. We no longer need the nc run to execute either. What we do need is to tell it what the file is that it's going to fetch, in this case 41020.exe instead of nc.exe. And we don't really need the local port. It's not going to hurt to leave it in, but we don't need it anymore because we're not using it to connect back with a shell. We already have our shell. We simply want to move 41020 onto our target machine, run it, and that will escalate our privileges. So we have all of the pieces here just to move a file onto the target machine. Before we do that, though, we're going to need to go back to our home directory where the 41020 file exists, and that's where we'll serve up our contents of that folder. And then we simply run it. Just as with the 39161, we give it the IP and the port for the service because it's using the same exploit. And if we go to the user's public folder, we can see that our 41020.exe has been added to the folder. And as I said, it's simply a matter of running it from there. So it'll take just a moment, and not too much fanfare, but check out who we are running as now. ntauthority/system, which does allow us to read the root.txt in the administrator folder on the desktop. For our final flag. So this machine is quite simply in woeful need of application and security patch updates. The Rigetto HTTP file server allows remote code execution because of the way searches are parsed by the software, allowing us to provide arbitrary commands following a null byte. The Windows Server 2012 R2 OS kernel itself is likewise out of date and still contains a memory access vulnerability by way of the region object, which is vulnerable to overflow. So the outdated versions of both the file server software and the OS kernel are the vulnerabilities in this case, and can both be fixed with regular update and patching policies and procedures.